Hi, in this set of lectures, we will look into sensitivity analysis, and we are looking at sensitivity analysis as it pertains to the linear programming. We realize that the majority of the systems that we optimize using LP are complex. As a result, when we formulate our LP problem, it is very likely that our LP problem has significant approximations. For example, when we define our objective function, the objective function uses coefficients of variables. These are actual approximations and they may vary to some extent depending on the system. And similarly, when we define our constraints, then the right hand side value constraints that we define are some approximations based on our analysis. But again, one can argue that those numbers can change as well. Finally, it is very likely that when we analyze the system to define our LP or to formulate our LP, we either knowingly or unknowingly do not include some constraints, or after you have performed your analysis, you may want to add a new constraint. So the concept of sensitivity analysis to see how sensitive, or on the other side, how robust our optimal solution is when it comes to approximations of coefficients of variables in objective function, maximum or minimum limits of constraints, that is the right hand side values, and addition of new constraints. For the scope of this class, we will focus on the first two. To summarize, we are going to see that once we have calculated the optimal values, if there is a change in the coefficients of objective function or in the right hand side values of limiting constraints, then how does that impact our final solution? So one obvious answer is that if there is any change, you rerun your analysis, but that is always an option. But we can still use the solution that we have made earlier. In addition, it also gives us tools to answer a few questions. So let's take a look. Consider an example that we had worked on earlier, and the example is the dog food manufacturing plant problem that we looked into. And production line of this problem produced two types of dog foods, which was bony and chewy, and each type of food had to be processed at two different plants. We had a limitation or a constraint of 40 hours for the manufacturing plant and 35 hours for drying and packaging plant overall. And then we also knew that it takes about 50 minutes per ton to manufacture the bony type and 30 minutes per ton for drying and packaging of it, and then about 24 minutes per ton to manufacture the chewy type and 33 minutes per ton of drying and packaging. Minimum constraints were that the company has to produce 20 tons of bony type and 5 tons of chewy type. The question that was given to us was that we have to maximize the production given the limits on manufacturing plant and the packaging plant's capability. When we formulate this problem, our objective function becomes z is equal to x plus y, and the constraints are 50x plus 24y is less than equal to 2400, 30x plus 33y is less than equal to 2100, x is greater than equal to 20, and y is greater than equal to 5. So in this case, we have two limiting constraints based on our resources, the first row 1 and row 2 here. Let's look at the graphical solution. The answer was that producing 30.97 tons of x and 35.48 tons of y within the given constraints gave the maximum value of objective function as 66.45. Let's see what happens to the objective solution if the objective function changes. One thing we want to notice is that we are only going to change one coefficient at a time. So either the coefficient of x or the coefficient of y. And then we will observe what happens to the optimal value and these basic variables, the solution of basic variables. Similarly, what happens when the right hand side value of a constraint changes? If the RHS value of one of the limiting constraints, so in our case, let's say we pick up the row 1, 50x plus 24y is less than equal to 2400. Let's say if we change the right hand side value of the limiting constraint to 2450 or 2350, how does that impact the optimal value and the basic variables. Again, we are only going to look into if any one of the value changes at any given time. We will solve our problem LP using R package, which is called LP Solve API. This is a package in R that allows us to solve linear programming problems, and in addition, it also gives us information that we can use to figure out the sensitivity of our LP output and our LP model.